So today is Monday, and we have 4 days to review, and then the final is on Friday. And I'm sure you're interested in how you did on that most recent test, and I will be getting those back to you, hopefully, at the end of the hour today. But today is going to be a review of two things. Polynomials, which are basically just equations that look like this. And a lot of times they were to like the power of 3 instead of just squareds, all right? And you were supposed to know if I put a negative in the front of this, it does something to the graph of it, for instance. Okay, so that's a polynomial. And I'll be telling you a bunch of stuff to remember about those for the final. And then there's another kind of function called the rational function, which is y equals 1 over x. And a little quick sketch of that. Do you remember it kind of looked like this, and it had asymptotes running like there and there? It's the only graph you learned with asymptotes, at least the first graph you learned with asymptotes. Is that ringing a bell? Okay. So if it's not ringing a bell, well, it's a good thing we're reviewing it because you had a whole unit on rationals, and they're on the final, of course, too. So if I wanted to make you really nervous about the final, I would tell you that most kids do a little worse on the final than they do on any other test because it covers so much stuff. If I wanted to make you feel better about the final, I would say that we aren't going to have the R3 type really hard. You know how there was only 4 of them, and you could get 1 wrong out of the 4, so that's like a 75% on those, and still get an A. We aren't even going to have that kind of problem. It's going to be mostly there's always variability in how hard the problems are for R2s, but they're supposed to be R2s, which are the relatively easy ones. It's just hard to remember all that stuff. Okay, so this is gonna be a fire hose of info, but not you just listening, because otherwise it won't stick. I'll remind you of some stuff, then I'll have you try one, and that'll make it stick. All right, do you remember that on a polynomial like this, I gave you a saying about the y-intercept. The y-intercept was where x is 0. And see, the reason that's powerful is because if I just stick a 0 here and a 0 here, do you get the y-intercept becomes 5? But then people have this misconception that it's just the last number. No, it's not just the last number. Because what if I factored it into something like this? Is the y-intercept the last number? No, it's not. The y-intercept is where x is 0. So you just stick a 0 here and a 0 here. And then it'd be 1 times 7. In this, okay, God, that's a terrible example. It turns out it was 7. But only because this was a 1. If I put a 2 here, then the y-intercept is where x is 0. And all of a sudden it's 2 times 7, which makes 14 would be the y-intercept. Okay. How about that negative in the front? I know some of you were thinking it. Negatives in the front tell you that the right side is going down. I know it goes through a y-intercept of 5. And then I just have to figure out whether it's going up on the other side or whether it's going back down on the other side, like this, or is it doing that? And the way you told that was if this was odd, they go opposite directions. So it'd be like this and this. Is that ringing a bell? I'm going to give you one. You try this. Ready? Write this down. Y equals x to the 5th plus 2x to the 3rd plus 3. Now just make a quick sketch. The y-intercept, you know, where it touches the y-axis is 3. Go through that. And then just decide if it's going up or down on the right. And then is it the same on the other end? Mauricio, what's the y-intercept? Yep. Because x is 0 cancels out those two, and then it's 3. So I touch 3, and then is it going up on the right? Mauricio?
Yes.
Because that's positive, it's going up on the right. Very good. And the last thing, Mr. Osberg, on the left, is it going down or up?
Down.
Because what told you that?
Because it's odd.
Because that degree right there is odd. That means it's going to be going that way. Okay. How about if instead I showed you a graph and I said, here's one. There's some function that looks like that. What could I tell me? Could you tell me about that polynomial? Well, it's going up on the right. That tells me something. If it's going up on the right, it must be positive in front. You know, like positive x to the something. You can't tell. From that sketch, you cannot tell for sure what the power is. But would you agree that since they're both going up, the power would have to be even? So maybe like x to the 6th, some even degree. And then the last thing is, the y-intercept is 0. So if I had said, is this the equation? You could go, no, that can't be the equation, because that would have a y-intercept of 5. But could this have been the equation? Yeah, maybe. Because if I stick in, remember the saying, y-intercept is where x is 0? If these two were both 0, then y would equal 0. I stuck in x is 0 and I got the y-intercept. All right, so that's enough about that stuff. How about this? Do you know that you can factor things? And if I told you that factoring was the most important thing you had to learn all semester, do you think there might be some factoring in the final? Of course. So if you do factor, what's the whole point of it? It's because you can tell the answers to this super easy. X equals -1 and x equals -3. Those are what makes this thing equal 0. Do you remember those? That's key. See, that gives me that equation, that gives me that equation. Now, what if they're more complicated? What if this was 2x plus 3? Then some people don't ever get it and they just think that the answer is -3, and it's not. What you should do instead is go, well, then I should say 2x plus 3 needs to equal 0. And then you solve that little tiny equation right there. So you set this part equal to 0 and that part equal to 0. So really, I shouldn't just jump to the answer here. I mean, you can, but if you want to know what's happening, you're really saying x plus 1 needs to equal 0, and 2x plus 3 needs to equal 0. So that's two ways you can solve one of these. So now let's see if you caught that. Write this one down, everybody. Even if you were drifting, get back to me. X plus 4 and 4x minus 1. Solve. The solutions are the x-intercepts, which makes y 0. That's one of the most critical things in higher algebras. X-intercepts are where y is 0. Y-intercepts are where x is 0. For somebody that just casually listening, you would have caught that, well, then -4 is one of the answers. But how do you do this kind? Jonathan, do you remember the equation I said to write? For this kind? What do I set it equal to? 0. Yep. 4x minus 1 equals 0. And then the first step is solving it. Forward. Add 1. 4x equals 1 and divide by 4. 1/4. Does that ring a bell? All right. And how about if you had to graph this one? What are these things? These things you just found are the x-intercepts. So this graph would touch here on the x-axis and there on the x-axis. So if you had to graph this, you'd go, okay, it touches at -4, and it touches at positive, was it positive? I think it was positive. Yeah, positive 1/4. So look, it touches at 1/4 and it touches at -4. And then this one, if I multiplied it all the way out, I'd be able to know that it was 4x squared in the front, which is positive. See the lead term? I know I'm going really fast, but you know, if you want to review all, we had 90 days of learning. 90. If I'm going to review that in 3 days, I got to go fast. It's not meant to be a teaching you how, it's a reminding you how. The lead term on this thing would be 4x squared. You go this times this, and that tells me it's positive in the front, so it's going up this way, so it must be going up, and then back up. And if I really needed to know the y-intercept, I'd set x equals 0. So if I really needed to know what that was, I would set x equal to 0, and I would solve it. And you'd end up with negative 4. 4 times negative 1 makes negative 4. So that technically right there would touch at negative 4. All right, that is a ton about polynomials. It's not everything. It's a lot though. And then rationals. I want to try to keep your review time down. You don't want to listen to me all hour. You want to have some time for questions. So here's rationals. Everybody, write this equation y equals 1 over x minus 3. That is a typical graphic question. And I told you several things. First of all, you got to know what this thing looks like, and then you got to know where it moved to. To me, right away, I see that and go, it went right 3. If you didn't remember that, you should give yourself notes on that. That went right 3. One of your test questions could be that simple. Which way did this graph get moved? The parent graph of 1 over x got moved right 3. And here's what the parent graph would have looked like. I just showed you that a second ago. It has asymptotes there and there, and everything would slide to the right 3. So my new graph, I'm going to use these red asymptotes and these yellow lines. If you can focus on the red asymptotes and the yellow lines, you'll see everything got shifted to the right 3. Okay, that's the graphing part. Oh, by the way, what if I said plus 8? Where would the whole thing move? Up 8, very good. Okay, and what if you had to add this to this? When you add fractions, which is what rational functions are, they're fractions, you need to get a common what? Denominator. Good. To get a common denominator, you multiply by the other denominator. So you go here and multiply by something, the other denominator, which is 2. And here you go and multiply by something, which is the other denominator, which is x minus 3. And then do you see that we have the same denominator? Now it's very tempting to multiply that out, but don't, because if you can factor it, you should. And this is factored. Leave it like this. That's factored form. If you multiply it out, I'm just going to tell you to factor it again. And then on the top, 2 times 1 is 2. Any small child can do that. Plus, and then how about that? Well, 1 times it means it's just 1x minus 3. So it's just x minus 3 again. If you left it like this, I'd cry a little bit and mark it wrong, because you should have known that you can put like terms together here. Final answer, 2 and the negative 3 can go together and they make negative 1. So I'm going to say x goes first and then the negative 1. And then tempting to multiply it out, but don't. Why don't you want to multiply that out? Because what if this part would cancel that part? You would want to do that if you could. And that's why it's best to leave it in factored form. All right, so there's a reminder of getting common denominators and adding things together. Do you always need a common denominator? No. Watch this one. That's a times. Do you get when times? You don't need a common denominator. You're just going to multiply. Ooh, I really wish they had never taught you cross multiply, because people think this is the time you cross multiply. No, you don't. Cross multiply happens when there's an equal sign in the middle. That's not what we have. So you just multiply it this way and this way, not like making a cross. That's different. That's when when the fractions are equal to each other. So this is just 6x over all of that multiplied out, and here's where you'd get it wrong. Doesn't that seem right? It is right, kind of, but the kid didn't take my advice of if you can factor it, you should. And if you do, you'll realize that something cancels. Because see, if all you do is multiply across the top and multiply across the bottom, you didn't do anything wrong, but that answer is not going to be right because you haven't simplified it. So what I think you should have done is factored out the 3 and the x out of the bottom. Do you get they both have a 3 and an x in them? And then this one would be x, because 3x times the x makes 3x squared. And this one would be a 1. And on the top, I have a 6x. And couldn't I factor that into a 3x? A 3x times 2? 6x is 3x times 2. I think factoring is the most important thing, because problems like that become easy if you're good at factoring. There's your final answer, 2 over x plus 1. And many of you could have got the blue writing, but couldn't get here because you're not good at factoring. You guys, do you get there's a 3x in both of them and it can be pulled out? That's probably the most important kind of factoring, because on the factoring test, I remember tons of people got that wrong. Let's practice one like that. Ready? 7x over x plus 3 times 21 on the bottom, I'm sorry, and on the top, I'm going to have 2x plus 6. Now, do you have to multiply it out first? No, I actually think you should factor it first and cancel stuff first and then multiply it out, because this will be really hard to multiply. It'll be a pain in the butt. So I would factor first. There's several places where things will cancel. Take a second, see if you know how to factor well.
Attention, 9th grade.
So here's what I would look for. You see how this 7 and this 21 both have a 7 in them? Then I would try to break out the 21 into 7 times 3. And then there's a 7 that's part of a multiply on the bottom and a 7 that's part of a multiply on the top. So those can be canceled. Then, who sees the other thing? Yes, Kai.
On the top of the right side, you can factor 2 out.
2 comes out. X plus 3 is left. If you don't get how to do that kind, just notice they're both even, so then 2 can be in them. Take the 2 out, put a parenthesis, and then try to figure out what would multiply back out to make 2x plus 6. Another way to do it is take this and divide by 2, and this divide by 2. And that'll tell you what to put on the inside. All right, cool. I got it factored now, Kai. Now, what was the point? Why did I factor that? It's something good happens now. Can you factor it even further? Nope. You don't want to factor it even further. You did it. You factored it. So now that cancels that. That is the good reason to factor it. Because x plus 3 on the bottom can factor out and cancel an x plus 3 on the top. And if you're like, it's not part of a times problem. Yes, it is. This is a times right there. So it's x plus 3 times 3. So that x plus 3 is part of a times problem. So now I can cancel it. It's gone. Only things left on the top are the 2 and the x. 2x. Only things left on the bottom is a 3. Okay, and then the last thing I want to remind you about. Don't write this, just listen. It seemed like this is really rebellious advice, but there's a reason. Don't ever divide. If they give you a divide problem, just don't do it. Because why? You can always turn it into a multiply. 2x over 3 doesn't change, but that changes to times. Flip it. 12 over 5x. And now it's a times problem. And now I can look for stuff that cancels. Ooh, there's an x and an x. They're both part of a times problem. I can cancel them out. And this 12, I can make that into 3 times 4. I saw the 3 down here, and it made me think, oh, yeah, I could put a 3 on the top. See, this 12 is 3 times 4. The 3's cancel. What is even left after all that? Well, there's still a 2 in the front and a times 4 on the top, which makes 8. And there's a 5 on the bottom. 8/5. That's it. Okay, now, true to my word, I'm going to give you a bunch of time now to work on these. Now, I've printed them because I think at this stage it's good to try some on paper every now and then, and gets you away from just like staring at a screen all day, every day. So, I've got a worksheet for everyone. I will tell you, I look through it and I'm like, oh, which ones am I going to have them skip? And the problem is, every single one of these is something that is like the final. On the plus side, you're getting great practice for the final. On the downside, I can't take any of them off, or you're gonna like not be ready for the final. But I am giving you plenty of time to do it. Come on, got your stuff together. All right, so this is the part where the kid next to you has got the same questions you do. I encourage you to ask them, and also encourage you to ask me. Happy to help you. Tip one of the stick back. Even the people that are taking a test can have one because these are just a worksheet. There you go.